Okay, so we talked about limits some in pre-calc. We mostly use limits to talk about like end behavior, primarily. Okay. In this class, we're going to use limits to talk about graphs at all points on the graph. So, a limit is a y value that a graph or function gets closer and closer to, but may not actually get to, as the x values get closer and closer to a specific value from both sides. So, if you have something like this, limit as x approaches 3 of f of x. They've already given us the answer on this. This is example 2 is going to be the answer. What I encourage kids to do, especially at first, whenever you're just starting here, is to, whatever your x is approaching, you can draw yourself a vertical line right there. So like at 3, I've got a vertical line right here. So what's happening is the limit is as I approach from the left side. So if I start on the left side of this graph, I want to go closer and closer and closer to that vertical line. And as I do, I get closer and closer and closer to that open circle, right? Now, the limit is the y value of that point. So the y value of that point is 2. So you're looking at this point right here where that x value is 3 and the y value is what you give as your answer. In order for you to have a limit, you have to approach the same point from both sides unless it's a one-sided limit. The circle can be open. It doesn't have to be defined at that point. Okay, so you can have a limit that looks like this where you have a hole in the graph. Now, if they ask you for if they ask you for f of 3, that would be undefined. Right? The graph does not exist at that exact point, but the limit is just what you're getting closer and closer and closer and closer and closer to, right? So we have a limit there. You also can have a limit that looks like this, okay? So again, you can see we're looking at x approaches 3. If we put us a vertical line right here, that means that our graph is, we're on the left side, we're going closer and closer and closer to that vertical line. That gets us here. On the right side also gets us here. So we are going to that open circle right there. The y coordinate is where we look every time for a limit. That value is 2. Now, in this case, for g of x, I've got an open circle, that dot's not included, but I also have that closed circle up higher, right? What would g of 3 be? It's going to be 4. It's the y value of that closed circle. These two things don't have to match for the limit to exist. Open circles, even whenever you got that extra point somewhere, it's okay. You're still getting closer and closer and closer and closer and closer to that y value of 2, right? So for limits, you can have open circles, right? You also can just, sometimes we'll see ones where it's just a solid line, right? And solid lines are just like a bunch of closed circles all together, right? So like in this particular case, it's still x approaches 3. We're still looking at that same thing right there. From the left, you approach this point. From the right, you also approach that same point. The y value of that is 2. Right, so it can be a solid line, or it can have an open circle and you can still have the limits. But it has to go to that same point right there. Okay, but there are going to be times when we don't have limits. Okay, that is going to be whenever we don't match up. Like from the right and the left, we're approaching different places. And I think we're going to see that down here. So if we look at this first one, x approaches positive 4, okay? So I like to go, x is approaching positive 4. I like to go put myself a dotted line right here, especially whenever you're just starting. Or in your mind, you're putting that dotted line right there. So if I trace this graph from the left, I'm getting closer and closer and closer to that spot. From the right, I'm also getting closer and closer and closer to that spot, right? So it's an open circle, but does that matter? No, it's okay that it's an open circle. So I'm just going to give, I'm going to look over here. I'm going to give the y value that goes with that. So that's going to equal 1. So the two pieces of your graph have to meet up for you to have a limit. Hopefully they've asked us about, yeah, the next one is going to be where we have an issue. I'm going to erase this so it doesn't get in the way of our next problem. Next problem, let's use red for that. I've got x approaches 1. Now right here is my 1. Okay, now from the left side, I go to this place right here. And then from the right side, I go to this place up here. Am I meeting up? Is it the same number? No. So when that happens, when they're not the same from the left and the right, we're going to say does not exist. So anytime you have a jump in the graph, you do not have a limit at that point. You can have a one-sided limit, like from the left or from the right, you can have a limit, but if it doesn't have the left or right with it, you don't have a limit at all. Okay, who can tell me what g of 4 is going to be? What do you think, David? 2. Because here we're looking at that closed circle, right? It's not the same as the limit, so we will get 2 as our y-coordinate there. And then we've got, let me use a different color here. We've got x equals 2. That's right here. From the left, I approach this point. From the right, I approach this point. What is my limit as x approaches 2 of g of x going to be? What would it be, Dalen? 1. Good. There. Okay. Now he's going to talk a little bit about one-sided limits. So this is the same graph. If we look at, let me use the highlighter instead of that. So if I look at 1 again, right here, if I have this little negative behind it, remember we talked about that yesterday, that means from the left. So when I'm approaching from the left, I go to this point right here. I can have a limit from the left. Michael, what's the limit from the left going to be of g of x there? Good. We're looking over here at the y-coordinate. It is 1. You could mistakenly look at the x-coordinate and still get that one right, but it won't work on the next one. For the limit from the right, if you take the graph and you trace it from the right side, you end up at this point right here. So Judy, what's the limit going to be from the right? It's going to be 4. We're looking right there at the y-coordinate. We'll get 4. Okay. All right, we got us a good complicated graph right here. How about you guys just try that one on your own? I'm going to freeze my screen so you can't see what I'm doing. Try that one on your own. Whenever a limit does not exist, technically it's good to write does not exist. There's not a lot of room right there. If you put D in E, it's okay. Are you supposed to write that on the actual AP exam? Not really. You're not really supposed to abbreviate because there's no like guaranteed acceptance. Will they accept D and E? Yeah, probably. As a grader, I would say they're usually going to take that, but So, sorry, Solomon and Alyssa, I forgot to record that part, but here are Michaela's answers to that piece right there. But you can have a lot of different options for those. Let's go back to my notes right here. So for example 4, the graph of f of x is shown to the right. What is the limit as x approaches 1? Okay, this is just a multiple choice question. What are we going to get here? D does not exist. Right there. Okay, and congratulations, you have correctly answered your first AP exam problem. This problem was on the 2018 AP exam. So, some of them are not all that difficult. Some of them are very difficult, but there are questions that you can do. Limit does not exist here because from the right and the left you're getting a different value, right? For those. Go ahead and look at this part right here. Go ahead and try those. Actually, try everything there. And then we'll talk about it whenever you get to the end of that. Specifically, I'm interested in the sketching. We're going to share some of those as well, because your graphs can look different for those. Okay, A is 0, B is 2, C is 1, D does not exist, E is -1, and F is 1/2. Does that look right? Also, I'm going off the top of my head, so hopefully I have been known to make a mistake or two. Okay. Questions there? We all good on this? Okay. All right. Number 2. I would love to see what you guys said in your own words on the difference between the limit as x approaches a of h of x and h of a equals c. What is the difference between having the limit as x approaches a and the h of a? So, anybody think they got a good way of putting it that they want to share? What do you got, Layla?
Like the h of a equals c just gives you a coordinate. You plug in the x value, or you plug in the a, and then it gives you the c.
Okay.
The limit is just
okay. I like the like plugging it in. You're looking at the specific coordinates, specifically of what? It's got to be the closed-in dot, right, or the solid line. Can't be an open circle for that. The limit. Anybody got a good sort of definition for what's happening there that makes it different? What do you think, Saul?
That statement's in limit notation and others and all that.
Okay, but they're different. Like you're looking at the same place, but they're asking for different things, right? So you can have a limit, but not have like f of a, h of a does not exist, right? That can happen. What do you think, Michaela?
it has to approach it from both sides of the function to reach c, and it could be an open or closed circle or an
Okay, so approaching from both sides. I like the word approaching, and if you just want to be like really informal, it's what you're getting close to, right? It's what you're getting close to. Do you have to get there? No, you just have to get close to it. From both sides, right? You might touch it, but you don't have to touch it. right there. So I would say something about it's what you're getting close to or approaching, whereas in statement 2, it's the value of the point, right? The y value of the point is what you're looking for that. Then I'm really interested to see what some of you guys have for your graphs. So I am going to borrow some more examples. So, and we're going to see if they look right or not. So, let's see. Let's see what mine is. I can borrow yours here. Take a picture and I'll go right back to you. And I have not looked at Michael's to see if it's right. He might have messed it up. We'll see. I know for sure some of you are thinking that looks way different than what I've got. But on Michael's, the limit as x approaches 1 is supposed to equal 4. Okay, is that true for his graph? It looks good. He's got an open circle there. Does he have to have an open circle? It could be a closed circle. It's fine. Well, actually, no. He does have to have an open circle because I'm not looking at the next statement. What's the next statement tell me? F of 1 is undefined. So that does mean it's got to be an open circle. For the limit statement, it doesn't matter if it's open or closed. But for the next statement, F of 1 has to be undefined. So pretty much, whatever your graph looks like, you've got to have an open circle at 1, 4. Right? That has to be the case. Now, what your graph looks like around that doesn't matter all that much. Then we got the limit as x approaches -2 from the left is supposed to equal 3. So right here is our -2. Does his limit from the left equal 3? Yep, that looks good. You pretty much have to have a some type of circle right there at x approaches -2. Then from the left, or from the right, we're supposed to get a limit of 1. So that means that we'd approach here. Does that look okay on his? Good. And then f of -2 equals 0. So he's got this point down here. That's his f of -2. That equals 0. Okay, so I think Michael has covered everything that he needs to cover here. The parts in between all of those points don't really matter that much. He used a straight line here, a straight line here, and then like maybe a sine curve over here, right? Looks great. Okay, doesn't look quite the same as some of your other ones there. So let's see. Let me find another one. Over here. Let's see what. Oh, this one's interesting here. Okay. Oh, that one's fuzzy. That's better. That's good. All right. Here's what we've got for you. There we go. Do you use straight lines for everything? That's fine. You don't have to have any curves. Is hers okay?
Mm-hmm.
What's the only problem with hers?
F equals -2, it's closed circles.
Okay. We got closed circles everywhere. Is this a function?
No.
It's not. And it does not specifically tell us this is a function, but it uses function notation. Like calls it f of x, which would imply that it is a function. Also, we know f of -2 has to equal 0 right there. So there's not multiple answers for that. There's just one. So these 2 dots right here, right here, this dot right here and this dot right here need to be open circles. Otherwise, everything about it looks okay. There for that. And then Dalen, let me borrow yours just to get one more look at things here real quick, and then we're gonna move on. Okay. This is just to show you she's got pretty much all the same points, right? but the curves and things in between look different, which is fine, right? Those are all good. Okay, any questions? Okay, I had two things for us to do. We get out here at 11:45, right? Let's see. I do kind of want you to do. I definitely want you to do this worksheet. These go pretty fast, even though the worksheet's gonna look like it's got a lot of stuff on it. We have a worksheet and a delta math. I really do need to do both of them. But I'm gonna go look at the delta math and see where I don't make too many problems, because I don't want it to be an excruciating homework. Here's the very first weekend of school. So when you go to delta math, if you'll go to Canvas first, here, and click on the assignment that says delta math, there's going to be a link right there, and if you just click that link, it should add you to the class. Like, you should all have delta math accounts already, and it'll just like add you to the class. Hopefully that link will work fine, and then the assignment will be there. Take a break and look up here. It says use the graph of the function f of x shown below in order to determine all values of a for which the limit as x approaches a of f of x equals -1. So it's not telling you to find the limit at -1. It's saying to give all the points where the limit would be -1, right? So -1 right here, is that a x value or a y value? Y value, because it's the answer, right? So what I would do here is think about putting a horizontal line through here at -1, right? That's where you're looking, because you're going backwards on this problem. So you're going to go across and see, oh, at -1 right here. Okay, now I've got a point right here, -1, but do I have a limit of -1? There's not a limit there because it's just a single point, right? In order for there to be a limit, you need, because it's not a one-sided limit, it's a both-sided limit, right? We need, like, the points to meet right there, the graph to touch. So this is, we need to consider it, but it's not it. Then we keep going on. -1, we got nothing, nothing, nothing. Oh, right here, I've got both sides have a y value of -1. So -2 would be one of my spots. Then I'd keep on going. What about at 4? Do I have a limit there? Yes, so 4 is another one. And then right here, I've got a limit also at 8. There. It's an open circle, but that's okay. You can have limits at open circles. So that one is a little bit tricky. Delta math tells me that assignment should take 20 minutes. I think some of you will be able to do it faster. If you find yourself taking more than 30 minutes, stop, quit, maybe come see me during EHS time on Monday and see if we can figure out what you're doing wrong. Do not spend more than 30 minutes on this delta math, okay? Because it's not my intention to give you a bunch of homework. Hopefully you'll be able to get to it and start it at least before you go. Okay, so there is a limit here, right? You've got a limit at here, but what is the value of that limit? Like at -8, what would it'd be 2. This question wants us to tell where the limit as x approaches a equals -1, so we wouldn't include that. We're only looking at, like, we're kind of just looking across, like, the horizontal line right here at -1. That's really the only place we're looking at. Right, it is a limit, it just doesn't equal -1. Yeah.